Arthur Stone of OEEsystems. He did the 1-minute pitch earlier, as you'll remember. Arthur has over 20 years' experience in senior engineering operations, technology management roles, and both in Ireland and indeed in international manufacturing companies. He's going to talk to us today about his belief that delivering tangible results in improving initiatives is really about the availability of quality information. Arthur Stone, please. Go for it.
Okay, well, it's 4 o'clock in the afternoon, and the first thing I have to say is fair dues to everyone who's made it this far through the day. A sign of real manufacturing professionals to be still working at 4 o'clock in the afternoon. Our business, some of you may have heard earlier, our business is about developing and supplying manufacturing performance management software and services to customers, primarily Ireland, the UK and Europe. What we're trying to do is we're identifying the opportunities primarily from competitiveness. So what's that? Reduce cost, improve quality, reduce scrap, eliminating waste, increasing output to deliver business performance excellence. That's what we see we're doing for our customers. Essentially, what we're trying to do is unlock those opportunities that are hidden within the manufacturing process and seeing what we can do. When I got the opportunity to speak at this event, I guess I had the option to talk about, I don't know, lean manufacturing, operational excellence, performance management, OEE, overall equipment manufacturing, or overall equipment effectiveness. But I thought it's 4 o'clock in the afternoon, I'm going to bore everybody to death, so I'm going to take a slightly different tack. And what I'm going to do is share with you 3 short stories, mini case studies if you like, 3 little findings that we had that maybe illustrate the kind of things we're discovering as we deploy these solutions throughout the customer base. So this is the case of a customer in the UK. They make paper bags. So we have 20 manufacturing lines running this software across the plant. And over each line, about 15 feet in the air, is what they call a production counter. It's the speed of the line. What we saw when we deployed the software was, even though the speed of the line was classically quoted by everybody in the building and in the plant as 550 bags per minute, everybody knew that's what it could do. Our software failed to find over the course of weeks anything near 550 bags a minute. In fact, we were struggling to show that they could do 500 bags a minute. So we had a contradiction. And as is often the case, I guess, the customer said, our concern is your software is not measuring correctly. There's something wrong. There's a bug. Can you fix it? So the first place you go, I guess, is the stopwatch. What can we find out? What is the line actually doing? These days it's not a stopwatch, so we get out our iPads or our iPhones and see what we could do. And the most we could see on a physical test and a physical time on the line was just under 500 bags a minute. So that was our first clue that there was something wrong other than the software. We were getting in or around 500 bags a minute. The next step was the machine, and this machine takes rolls of paper on a big flywheel and folds bags and glues bags. We looked at the pulses coming out of the machines, and as you might expect, we were getting 1 pulse out of the machine for every bag. So we knew we didn't have 1.2 or 1.3 pulses. We were getting 1 pulse per bag, and we knew we were getting 500 bags a minute. So that was the first confirmation. The second thing we did was we got ourselves a cherry picker and went up 15 feet in the air to take a look at these control units and these displays. And in the back of the display unit, we found a very interesting little knob called adjustment. And this little knob matched the pulses coming in from the line to the display. So you could effectively tune it. And for the last God knows how many years, everyone believed that what we were seeing on the overheads, because it was sacrosanct, it was there, it was visible, was the speed of the lines. In fact, most of them were adjusted 10 or 15 or even more % too high. And without the software, I think without being able to prove that and count it and with an alternative means, this would have been the speed of the lines. So we demonstrated clearly the speed of the lines is 500 bags per minute. That's what they can do. Bad news maybe for the company, but at least it's reality and it's the truth. Fascinating little knob on the back of the units. I'll take another case. This is a This is a company in France. They make injection molded parts, about 35 lines or thereabouts. And what we were seeing in this installation, in fact, it was during the commissioning phase, so the software was maybe in place, I don't know, a matter of weeks perhaps. They believed that so what they did was they make plastic parts in a molding machine. The molding machine spits them out onto an inspection table, and somebody inspects the parts and decides they're good or bad. They notionally believe they had about a 1% rework rate. They can recycle the plastic. So if it's a bad piece of plastic, you put it back into the process, it gets crushed and comes back through the machine again to be made another time. That's the process they use. They thought about 1% of the product did that, but we were showing much closer to 3%, and while 3% isn't huge, it's 3 times what they thought it was. So yet again, customer said, don't know, something wrong with the software, very high numbers on yield, will you take a look? And we went off on another investigation to find some fascinating stuff. This is the kind of top-level report we were displaying that said, okay, they're on orange. Do I have a little pointer? I do, maybe. Will this work? Yeah, there we go. So that's our orange yield loss line. That's our rework line, top of all our losses. So it's 4th on the scale of losses, running down in or around 3%. So we said, okay, it definitely is around 3% as far as we can see. It's not the 1% that they believe. Or their 4th biggest loss, and we were fairly happy with that. The second thing we did is another analysis as we started to drill through the data and see what might be happening. And we found an interesting scenario. This is the performance on each of the shifts. So green is good production, blue is stopped production, that little pink strange salmony colour is slow running, and this is the quality losses at the tops. And as we looked across the shifts, shift A, shift B and shift C, we found some sort of an anomaly. One of the shifts was definitely out of kilter. And that was our first clue as we drilled through down into the data that there's something happening. So that's about 4 or 5 times the scrap rate, the rework rate, in fact, of the other 2 lines. So we did a little bit more digging, and we found this interesting pattern. This is the yield loss, the rework by day on this shift, and then there's a gap for the other shifts, and that's the next time that shift was on. And we saw this fascinating, unusual hourly peak. So you can see that there. So about every 3 or 4 hours, we had a peak in rework. Very, very strange, on one shift. And what we found was this. The machine runs mostly all day long. It opens and closes, makes parts, spits them out onto the conveyor, out onto the table for inspection. So when everybody goes to meal break, the machine continues to make parts. And when they come back from meal break, instead of a regular production run, there's a backlog. Lots of parts on the table, lots of inspection. You've got to pick up the ante, and you've got to inspect all these parts and catch up with the machine again. Well, there's one very easy way of solving that problem, and that is you gather them all up and you put them in the rework bin. And that's what they were doing. At the end of one person was doing, at the end of every break, they cleared the table, put them in the bin. The plastic came back out again. It didn't really matter. Played hell with their production and their capacity, and that's what they were doing. So what was interesting from our perspective was the customers didn't see this. The customer didn't see this problem. What they were looking at was in and out, plastic in and plastic out. And all the plastic that went in eventually came out. Some of it had 3 or 4 cycles through the plant to do that, but it all came out. So again, we were able to drill down through the data, what exactly is happening. And these are real stories from manufacturing. I'm obviously not mentioning companies' names for a very good reason. So one last story, and some of you might relate to this one. This is a company in the UK. They manufacture contact lenses. And they have 2 problems that we've seen in plenty of plants. I'm sure you relate to it. One is that not every time, but lots of times when they do a planned intervention, a planned maintenance, it was a real struggle to get the lines back up and running again to the pre-service levels, right? So you'd take the line down, do your service, make your changes, do your cleaning, and then you'd struggle for literally days to get the line back up to the performance pre the service. And the second problem they had was that when there was a breakdown on the line, what was the criteria that was agreed to say the line was back and running again? And many of you that are involved in manufacturing, either from the engineering side or maintenance side or from the operational side, will know that usually the criteria is your engineer or maintenance person comes in, does the job, fixes whatever has to be fixed, declares victory, and leaves. But that may or may not be right. The line may be running well, it may not be running well. And typically, it's an engineer, and I used to be an engineer, so I can say this, they declare when the line is running or not. But often, our operations colleagues were very frustrated because the line wasn't running as it was before. So they didn't consider the problem closed. And they were left in this limbo land. So this company wanted to sort these issues. And what we did with them is we built a new piece of software that sits on top of our own system, which is based around process control. So what they were seeing was this. There's your PM service. So what you've got here is, that's their target OEE. 85% is where they wanted to run. This is a period of about 6 weeks or thereabouts. So you can see their trend. They get the normal dips and ups and downs. There's their service. And you can see that was the performance on target for the days before the service. They took it down to do the service. So that's the dip you'd expect to take the line down. And it took them 16 days to get back up to steady state. So this was, as you can imagine, breaking their hearts. And maybe it's not 16 days for many of you, but I'm sure you recognize this issue. And the second part of that problem was when they have a normal equipment failure, again, it takes forever to get it back up and running. It gets worse and worse and worse, and then who knows how long it takes to get back up, where you can say the machine, the performance of the line, as opposed to the operation of the machine, the line is back performing to where it wants to be. They wanted to tackle these two issues. So we worked on them to take a variation of statistical process control, and what we did was we said, okay, let's look at the capability of the line. Let's look at a process parameter. In this case, we looked at dropped lenses. So when the robots pick up the lenses, they take them out of the molding machine and drop them onto a set of pallets, effectively. And we said, okay, what's the capability of the machine to do this? And we worked out a capability, which is that blue line there. So that's what the line is capable of doing. How many drop lenses? It's about 1 drop lens per sample, 1.125 to be absolutely mathematically accurate. The line is capable of that, and it's quite happy to run along like that. It's not perfect. It does drop lenses. It does miss lenses, but it's okay. And then every now and again something happens. So what we did was we said, okay, when the line goes out of control and this problem, which is a process parameter, dropped lenses, gets out of control, we initiate an out of control. In fact, the software initiates an out of control procedure. And what this is typically is an operator cleans the heads, does whatever the routine, whatever they can do, 15, 20-minute intervention to do something on the line, something that they within their capabilities to get the line back up and running. In this case, what happens is they do that. That's about I can't read that from here, 15, 20 minutes maybe, another 20 minutes or thereabouts, another 20 minutes. The problem is getting worse. So as the operators try and fix it, it's not really working. And what we do then is we say, okay, we've now got to a point where the first level intervention is done, and the software emails maintenance or engineering or whoever you want to say, first level intervention isn't working, we're still running at an unacceptably high level, we need to escalate the product. Next, please, next people up to fix it. And then what happens is at the end of the shift, we're still out of control. So this is going to break across the shifts, and then we email the incoming shift team and the incoming shift managers to say, you're going to walk into this problem. Be aware this is running in your process. This problem is live, it's not been fixed, and it's still running at very high levels. And eventually, after working on it, trying to fix it, maybe having some success, having some less success, we'll get it back under control. And what's interesting from our point of view and from this company's point of view is the software decides based on the performance of that parameter when the job is finished, which is a fascinating cultural shift. So instead of our engineering colleagues saying, that's okay, I've come, I fixed it, it's done, the software says, yeah, you're done, we're back in control, you can go home now. And it doesn't really matter how long that takes. Obviously it matters, but it's not dependent on how long to the end of the shift, how long what the resources are. That's a true process parameter. It's made huge, as you can imagine, a huge impact on the process operation and a huge cultural change for people to understand that it's now truly performance-based. Your maintenance intervention is now performance-based. So now what we see, there's a robot failure about a month later, same day recovery. Robot collapsed, and they were back up same day, right, based on that procedure. And this is a PM service. About a week later, 28th of January, they do a preventive maintenance schedule, and they're up within, 2 days, 1 day, 2 days, instead of the 16-day period. So this has made a huge difference to the operation. And you can see there's no longer any negative impact of PM. So doing a PM now doesn't have this long 10, 12, 16-day impact on the lines. And in fact, if you look at their performance level, their target performance level, and this is their 7-day rolling average, so this is the performance with all the bumps and taken out of it, you'd wonder where the service level was, where the PM was. And in actual fact, the PM was there. And you can see very quickly, even on a rolling average, they're back up to the performance before. That's the kind of impact we're having. So, A few little takeaways from the little stories, I suppose, late in the afternoon. The first thing I'd say, if you're not automatically collecting this kind of data off your production line, it's highly likely these kind of things, maybe not these, but similar events are happening in your process, and you probably can't see them. These are the hidden events I'm talking about. May not look like this, but I guarantee you there's something in your process that's hidden if you're not collecting that data. If you are collecting data, and you've got some sort of a monitoring system, manual or automatic or whatever else, I'd say to you, have a look at the funny data, the outliers, the strange data, the stuff you might be inclined to disregard. There's often a story there, and where there's a story, there's an opportunity for improvement. And the last thing I'd say to you is, if you do have a handle on this type of information, fair dues to you, well done, you're on the ball. Thank you for your time, folks.